Hey guys, this is just part 2 of equations with variables on both sides. Notice I have an equation because I have equal signs. I have something on either side, and we're going to look at this problem here. And we're going to see if this could possibly be true. Besides looking at it, let's see if I can plug in some variables so that I can prove that this is true. If x equals 2, then 2 times 2 should equal 2 times 2. Yes, 4 equals 4. Yep. What if I plug in x equals 0? Well, 0 equals 0 because 2 times 0 is 0 on both sides of the equation. So there are many variables for which 2x equals 2x could be true. This equation up here, 2x equals 2x, is considered an identity. An identity is simply an equation. Notice I have equal signs. Anytime I have equal signs, I have an equation. It's an equation that is true for every value of the variable. What that means is whatever my x equals, this equation is still going to be true. Let's look at figuring out how something might not be an identity. If it's not an identity, then it's something that is super, super sad and it has no solution. There is no value for x that would end up making it true. Problems that have no solution might look something like this. Let's look at 6m minus 5 equals 7m plus 7 minus m. All right, this looks a little bit big, and I've got variables all over the place on this. So remember, what I want to do first is I want to get all of my m's on the same side. I have 2 m's over here. Well, I have like more than 2 m's. I have 7 and I have 1, but I have 2 terms that have m's in them. On this side of my equation, I only have 1. So I think it's easier to move just this 1 over to this side. So how do I do that? This is a positive 6m. So I need to add a negative 6m. So 6m minus 6m minus 5 equals 7m plus 7 minus m. Don't forget to do this to the other side too, minus 6m. Holy moly. All right. Let's zoom in over here. So I end up crossing out my 6m minus my 6m because that equals 0. So I'm left with negative 5 on this side of my equation. Now over here it's a different deal. And I want to rewrite this so I have all of my m's together. So I have 7m. All right, I got this guy. I've got minus m. I got this guy. And I've got this minus 6m. Don't forget your constant over here, plus 7. Yikes. All right, let's simplify before we go any further. Negative 5 equals 6m minus 6m plus 7. Oof, this isn't looking so good. Negative 5 equals 0 because 6m minus 6m is 0m, and 0m is 0. So I get 0 plus 7, which is just 7. Oh no, we have a problem. Can negative 5 equal 7? Is that true? No. At no point when I'm on my number line does negative 5 equal 7. They're at totally different points. They can never be the same. Oh no, this problem has no solution. It doesn't matter what I end up plugging into my m's up here. There is no value that will make this solution, this problem work. This problem has no equation. No solution. So let's look at one more example together. All right, let's go to page 36 in your note-taking guide. It's number 2A. It's at the top of the page. It's the back side of lesson 2-4 note-taking guide. You have this problem, negative 6z plus 8 equals z plus 10 minus 7z. I want to know I need to solve this equation and figure out if this problem is an identity or if it's super sad and it has no solution. So I need to know which one, what's the state of this particular equation. So let's solve here. Remember, the first thing I need to do is what? First thing I want to do is I want to get all variables on one side. Hopefully what you realize you need to do now is you need to move 6z over to the side with all of these z's. We want z over here. I've got one z here, I've got another z here. So it's just easier to think about moving this z over to this side. But be careful here, because this 6z is negative. Oh my. So if I recognize that this is negative, what is the opposite of a negative 6z? It's a positive 6z. You haven't seen ones like this before. It might help you to think of rearranging this problem on this side so that you end up with something that looks like this. 8 minus 6z. That is the same thing as negative 6z plus 8. All I'm doing is I'm just swapping my terms. 8 minus 6z, because now I see that I'm subtracting, or it looks like I'm subtracting. So the opposite of that is addition. So I'm going to add 6z. It's the exact same thing I had before, it's just terms are rearranged. And then what I do to one side, I've got to do to the other. Okay, now let's simplify and combine like terms. That's step 2. Simplify by combining like terms. So what terms are alike? Well, here, this ends up crossing out because that equals 0. So I'm left with this 8 equals z plus 10 minus 7z plus 6z. Okay, I'm going to rewrite this side so all of my z's are together. So I get z, got this one, should do it in pink. I've got minus 7z. Make sure you bring that sign with you. That sign has to go with it. And then I've got this new plus 6z, got this guy. Don't forget, you got to bring your constant down, plus 10. 10 is my constant. It's a constant because it has no variable with it. So I get 8 equals, let's simplify. What is z minus 7z? Well, if we recall, 1 minus 7 is the same as 1 plus a negative 7, which was negative 6. So I get negative 6z plus 6z plus 10. Oh, this isn't looking so good. Negative 6z plus 6z is 0z. And 0z is just 0 plus 10. And 10 does not equal 8. To indicate that something is not equal, I can draw an equal sign and a line through it. That basically is telling me 8 does not equal 10. Okay. Now that we have that, is this problem an identity or no solution? Well, if they don't equal each other, then there is no solution. There is no value for z that ends up working and proving this true. This equation has no solution. Hopefully you filled out 2A in your note-taking guide. If you didn't, you need to restart this section and make sure you fill it out as we go. Let's go to 2B. Last one we're going to do together, and then you're going to check your understanding. All right, let's look on our note-taking guide at the top of the page, just under the last one we did. It's page 36, exercise 2B. And you get this problem. 4 minus 4y equals negative 2 times the quantity of 2y minus 2. This one's a little bit more complicated. So I reminded you of what we did last time with the 5 steps to solving a multi-step equation. That's this stuff down here. Okay, take a look at those. The first thing we have to do before we can even look at doing those steps is we have to move all variables to the same side. All right, that's the one exception to this. Actually, it's not even the first thing we do. It's got to go down here. It's before I can combine like terms, but after I use the distributive property. So let's go through here. The first thing is to get rid of fractions and equations and decimals. I don't have any, so I'm not even going to worry about that step. But I do have the distributive property, so I have to do that first. Where do I have the distributive property? It's on the right side of my equation right here. So I'm not even going to touch the left side. I'm just going to write it again, and I'm going to have to deal with this over here. Remember that this is -2, so I've got to take the sign and the number and bring it over here and multiply it, which gives me -2 times 2y. I'm going to keep that sign. That's got to come down. And then I'm going to take this -2 and I'm going to multiply it by the 2. Protect your negative. Okay, so at this point, by the way, you also could have written this as positive and negative here. Okay, so now I need to do the multiplication and simplify. So we got 4 minus 4y. What is this? Well, this is -4y, and this is minus -4. All right, I still have to simplify a little bit more. 4 minus 4y equals -4y. 2 negatives equals a plus. Okay. Whew. Now I have to do moving all variables to the same side. So is there one side that has more y's than the other? Actually, no. So it doesn't really matter which side we want to move them onto. Why don't we move them this direction today? So if I want to get my -4y out, I'm going to have to add 4y to this side. What I do over there, I've also got to do over on the other side. All right, I have positive 4y on both sides. So let's simplify. At this point, my -4y and my positive 4y cross out, so I'm left with 4 on this side. Uh-oh, my -4y and my positive 4y cross out on this side too. Fortunately, I'm still left with a positive 4. Is it true that 4 equals 4? Yes, in any case, 4 always equals 4. So what this tells me is if I have the same number on both sides of my equation, then my equation is an identity, because this proves true. There is a solution that I can plug any number in for y, and both sides of this equation are going to end up matching. This is an identity. I'd like you now to check your understanding on page 36, and I'd like you to complete exercises 2 and 3A and 3B. On your own, tell me if 3A and 3B are identities or no solutions. And the way that you have to prove that is to solve for y, just like we've done in the last 2 problems. If you get stuck, rewatch these parts of the video and see if you can figure it out. Good luck, and I'll check your work tomorrow in class.